Calorimetry is a method used to find specific heat capacity by finding the energy or heat transferred from one substance to another. Now, specific heat capacity is an object's resistance to change its temperature. Its symbol is C sub P, and the C, of course, stands for the capacity part, but the C is really standing for that it's at a constant pressure. There's different values for specific heat capacity based on whether it's a constant pressure or, let's say, a constant volume. In most of our situations, we're going to be dealing with atmospheric pressure, things open to the atmosphere, and so we will have these values. The units are joules per kilogram times degree Celsius, and our equation is that the amount of heat transferred is equal to the mass times that specific heat capacity times the change in temperature. Now, what we're referring to with specific heat capacity is, let's say we have two substances. First, aluminum, where specific heat capacity is 899 joules per kilogram times degree Celsius, versus something like water, which has a higher specific heat capacity of 4,186 joules per kilogram times degree Celsius. For the aluminum, this means that it takes 899 joules of energy to increase 1 kilogram of aluminum by 1 degree Celsius. However, if I have 1 kilogram of water, it takes 4,186 joules of energy to change its temperature by 1 degree Celsius. So we see that water has a larger resistance to change its temperature. It takes more energy to change its temperature. This is why when you go to the beach in the springtime, even though the sand is relatively warm, because sand has a lower specific heat capacity, it takes less energy to bring it up to temperature to the temperature of the air. The water stays relatively cool in the spring because it has not absorbed enough energy to bring it up to the temperature of the air. The opposite is true in the fall. In the fall, the water is still relatively warm even though the outside air temperature is cool. It takes a lot of heat removed to lower its temperature back to the temperature of the air. The sand, however, has a low specific heat capacity, so it brings its temperature down relatively quickly. Another example would be, let's say you put a baked potato in the oven, you wrap it in the aluminum foil. When you pull it out of the oven, you can remove the aluminum with your fingers because the aluminum has cooled down relatively quickly. It doesn't take a lot of energy to bring the temperature of the aluminum back down to the room temperature in the air. However, the baked potato is a water-based object, and so the baked potato stays warm for a relatively long amount of time because it takes a lot of energy removed in order to bring it down to room temperature. So the differences here again, specific heat capacity is referring to an object's resistance to change that temperature.